Welcome to EDU World Space.
Problem 3.111. In this problem, we have to calculate equivalent force that is acting on this system and line of intersection of the force with the edges of this suitcase. Let us consider this point to be G. So this is our point G, and first of all we have to calculate the equivalent force. So for the calculation of equivalent force, these forces has to resolve along two perpendicular axes. So let us consider that this is our x-axis and this is our y-axis. So we will resolve all the forces along these axes. Since these three forces are already along x-axis or either along x-axis or y-axis, the only force is out of this axis is 212 Newton. So we will resolve this into its component along x-axis and y-axis. So first of all, let us consider that this angle is theta. So we can get the value of theta as in this diagram tan theta will be vertical distance. This distance is given as 280 mm and this distance is given as 450 mm. So this will be 280 divided by 450. So from here we can get this will be 28 divided by 45. So we can get the value of sine theta, and sine theta comes out to be 28 divided by under root of 28 square plus 45 square, and which comes out to be, this value is 0.5283. And similarly we can get the value of cos theta as 45 divided by under root of 28 square plus 45 square, and this comes out to be 0.849. So the cos theta and sin theta now is known. So this angle is theta, so this will be theta. So now this 212 can be resolved along x-axis and y-axis as 212 cos theta along x-axis and 212 sin theta in negative z-axis. So we can get the value of resultant force that is acting on this system as R is equals to, this 100 Newton is along positive x-axis, so this will be 100 I cap. This 180 Newton is along negative x-axis, so it will be minus 180 I cap. This 212 Newton force will have a 212 cos theta along positive x-axis, so it will be plus 212 cos theta I cap, and it will have a component in z-axis as minus 212 sin theta j cap, and this P force that is 138 Newton is acting in downward direction, so this will be minus 138 j cap. So we can collect the coefficients of I cap and j cap. It comes out to be 100 I cap minus 250 j cap. So we got the resultant vector in its vector form, but I cap and j cap both the axis is our assumption. This was not mentioned in the problem. So we will write this resultant vector in some another form, that is we can get the magnitude of this resultant vector, and that will be under root of 100 square plus 250 square, which comes out to be 269.258 Newton. So our resultant vector will be 269.258 Newton, which is making an angle theta in clockwise direction with positive x-axis, and this theta will be tan inverse y component, that is 250 divided by x component, that is 100, and that comes out to be 68.198 degree. So this is the answer for first part. Now in second part they are asking to find the point of intersection of line of forces with the edge of the suitcase. So first let us draw the suitcase rough diagram. So this was the suitcase. Now we are going to calculate moment about point G in actual diagram and in equivalent diagram that we have drawn just now. Why we are considering here the point G? Because these three line of action of the forces are passing through the point G, so they will have zero effect on the moment calculation. So we have to worry only about the moment because of this 100 Newton force, and this 100 Newton force will have a line of action along this line, and we can get the value perpendicular distance between point G and line of action, as this distance is given as 280 mm and this distance is 100 mm, so this distance will be 280 minus 100, that is 180 mm. So we can write the moment value from the actual diagram as moment about G comes out to be, since this is going to cause a clockwise couple, so this will be minus 100 multiplied by perpendicular distance, that is 180 mm, and this moment should be equal to the moment that is applied by this resultant force in equivalent diagram. So let us say that this was the side AB and this was point G. So let us first say that line of intersection or line of action of the resultant force intersects the line AB at some point, let's say M, and this M is at a distance D from this line G. So if we draw here the resultant force that we have calculated here as 100 I cap and minus 250 J cap, so 100 I cap will be in this direction, so this will be 100 Newton, and in downward direction this will be 250 Newton. So we can calculate the value of this resultant force about point G, and this will be equals to, since this 100 Newton is at a distance of 280 mm, that was given in this problem as this distance 280 mm. So this is going to cause a clockwise couple, so minus 100 multiplied by 280, and this 250 Newton is going to cause counterclockwise couple, so this will be plus 250 multiplied by perpendicular distance, that is D. So if we solve this, so this D comes out to be 100 multiplied by 280 minus 100 multiplied by 180 divided by 250, and this D value comes out to be 40. So this 40 will be in mm. So we got the first intersection point, that is on the edge AB at a distance of 40 mm from the point G. So if we talk about the distance from point B, this distance is 80. So from point B, the distance will be 80 plus T, that is 120 mm. Now for the second point of intersection, we can again redraw this sheet case, and let us say we have already seen that. Let us say that here, so this was the our resultant force. So resultant force will be in fourth quadrant. So this can intersect the side B. This was point C, so it can intersect the side BC. So this is B and this is C, and this was point G. Let us say that our resultant force is intersecting the side BC at a distance. We can write this distance as, let us say this distance at Y above the point G. So we can calculate these values. This component of the resultant force was 100 Newton and the vertical component was 250 Newton, and this distance was given in this diagram, and that was 80 mm. So this distance was 80 mm. So we can again write the moment equation from actual diagram. So from actual diagram we have already calculated here. This was the moment from the actual diagram, so we can use it directly here. It will be minus 100 multiplied by 180, that is equals to moment caused by this resultant force, that is 100, and this will be minus multiplied by perpendicular distance Y, and this 250 is again going to cause a clockwise couple, so it will be minus 250 multiplied by the perpendicular distance, and its perpendicular distance is 80 mm. So from here we can get the value of Y, and Y comes out to be minus 20 mm. So what does this minus sign indicates? This minus sign indicates that this point, since we had assumed here y direction above the point G, so it will be downside from the point G. So the distance from point B will be, since the G is already at 280 mm distance and this distance is 20 mm, that is this point of intersection. Let us say this point of intersection was N, so N will be at 20 distance below the point G. So the total distance from point B of point N will be 280 plus 20, that is 300 mm from point